Fukushima Daiichi nuclear power facility experienced a massive earthquake and subsequent tsunami in March of 2011. The resulting disaster changed the way we think of nuclear power. Nuclear power reactors have uranium oxide fuel in the form of pellets. They're inserted into a metal tube made of zirconium, and this resulting structure is called a fuel rod. Many rods are assembled into what's called the fuel assembly, this rectangular-looking thing here that's usually 4 to 5 meters long. And these are lowered into the reactor vessel itself via a crane. The reactor is put inside a containment building, shown here on the right. The idea behind the containment building is that should anything happen, it isolates the reactor inside the building itself.
The explosion at Fukushima was caused by the presence of large amounts of hydrogen. The hydrogen was produced by reaction of water with zirconium metal that's in the cladding around the fuel rods. So the reaction goes as zirconium metal reacts with water vapor to form zirconium dioxide plus 2 moles of hydrogen gas. So let's ask the question, if 5% of all the zirconium metal in the reactor were reacted with water, what volume of H2 hydrogen gas would be produced? Now, obviously we have to calculate how much zirconium metal is in the reactor. The reactor was a boiling water type reactor made up of assemblies of rods. So there's about 96 rods per assembly. These types of reactors, there's anywhere from 400 to 800 assemblies, which gives us, if you assume that there were 500 in there, 48,000 rods. Each rod has a zirconium metal cladding that's basically a tube. It's about 5 meters long, or 500 centimeters, about a centimeter diameter, and it's about 0.8 millimeters thick, or 0.08 centimeters. So we need to get the volume first to calculate the mass of this thing. So the volume is basically this area, the cross-sectional area here, times the length. The cross-sectional area is roughly the circumference times the thickness of the wall. So that's pi times 1 centimeter times 0.08 centimeters times 500. That gives you the volume. And if you do that, you get 126 cubic centimeters. The mass can be calculated by looking up the density on the periodic table. So that gives you the 126 cubic centimeters times 6.49 grams per centimeter cubed. So the mass ends up being 816 grams. We get the moles of zirconium in one rod as this 816 grams divided by 91.224 grams per mole. And that ends up being 8.94 moles. So if only 5% of that reacts in a given rod, that says we could calculate the moles of zirconium reacted by multiplying 8.94 moles by 0.05. And that gives you that the moles that actually react is, per rod, of course, is 0.447 moles. Well, if 0.447 moles per rod reacts, it's going to produce, according to this equation, twice that many moles of hydrogen. So the moles of hydrogen per rod is going to be 2 times 0.447, which equals 0.894 moles. It should be a 4, yep. The volume of hydrogen per rod is going to be this many moles times the volume of a gas at standard temperature and pressure. 1 mole of a gas at standard temperature and pressure. So 1 mole of a gas at standard temperature and pressure occupies 22.4 liters per mole at STP. So that times 0.894. And that gives you almost exactly 20 liters of gas per rod. So the total is going to equal 48,000 times 20 to get the total volume is 960,000 liters of hydrogen. Now, of course, the hydrogen itself is not the problem. What happens is that the hydrogen reacts with oxygen that can leak into the containment building. And of course, what happens is the hydrogen reacts with the oxygen to produce water, which doesn't sound too bad, except that the heat released is 286 kilojoules per mole of H2. So the total energy that's released upon reacting all this hydrogen can be calculated. That's just going to be in joules, 286 times 10 to the 3 times the moles of hydrogen per rod. So that's 0.894 times the number of rods, 48,000. And that equals a whopping 1.23 times 10 to the 10th joules. To put that in perspective, one stick of dynamite has around 2.1 times 10 to the 6 joules, 2.1 megajoules of energy in it. So the number of sticks of dynamite that this energy is equivalent to is just going to be this 1.23 times 10 to the 10 all over 2.1 times 10 to the 6, which equals 5,800 sticks. A whopping explosion.
This is a surveillance camera image showing much of the Fukushima facility in the moments before the hydrogen explosion. One of the reactors, Fukushima Reactor 3, exploded due to hydrogen. Of course, the cloud that you see there sent radioactive contaminants everywhere. The entire containment building was destroyed.